The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international dateline, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
If you're a fan of Dr. Pimple Popper, you're probably freaking out right now, itching to squeeze out every little blackhead from those lip contours. But this is actually a hill formation that you can find in Garb, Sudan. Knowing that perhaps makes it all the more creepy because it looks like the crack in the middle is swallowing up everything around it. This black hole scenario brings to mind our next stop, Vostok Island. This eerie spot is a 59-acre coral atoll situated in the southwestern Pacific Ocean, about 400 miles northwest of Tahiti. If you check it out on Google Earth today, it looks like it's been totally blacked out, sparking all sorts of wild theories. People keep saying that this place is some top-secret base, or even a fictional island straight out of Lost. But what we see here is actually just a dense, dark green forest made up of Pisonia trees. Since nobody lives there and hardly anyone ever visits, the island is pretty much untouched by humans. This massive star, or mandala, is situated just outside Beatty, Nevada. It has got the internet all puzzled with people trying to figure out if it's evidence of some kind of extraterrestrial activity. To add to the mystery, this spot is right by the Tonopah test range, which is also known as the famous Area 52. Despite its creepiness, it's probably just one of the thousands of crop circles that gained fame after Google Earth came along. This spiral formation right here is also located in Nevada, and it definitely looks like another chilling crop circle. But things get even stranger if you use the street view option. As you zoom in closer and closer, you'll notice that it's made up of carefully arranged rocks. This labyrinth, so to speak, is part of an open-air museum situated in the ghost town of Rhyolite. And if that's not creepy enough, take a look around and you'll see dozens of eerie men in white cloaks. Despite their lifelike appearance, these silhouettes are actually statues from an installation created by a Belgian artist in the 80s. Even stranger than stumbling upon a large circle on the ground is finding a bunch of them. Our next location in Wyoming is filled with peculiar circle structures to the point where it's hard to count them all. During the 20th century, this U.S. state shifted from a farming economy to an industrial one, dominated by the extraction of oil, gas, and coal. So, these circles are likely remnants of a tank farm. I mean, places where oil storage tanks used to be located. If you want to avoid nightmares, I highly recommend not searching for the mausoleum of Emil Becker in Poland. If you happen to find it by using the Street View mode, prepare yourself to face an abandoned place with the most terrifying sculpture there is. Oh, the creeps. Keeping on the spooky side, let's head to an isolated corner of Kazakhstan, where you can find a pentagram etched into the Earth's surface. This formation is huge, measuring roughly 1,200 feet in diameter. Before you jump to conclusions about this formation being related to some kind of underworld deity worship, it's worth noting that the pentagram actually turns out to be the outline of a park designed in the shape of a star. The star shape is marked by roadways, which are now lined with trees, making the star shape even more distinct in aerial photos. You can spot this peculiar symbol from quite a distance. At first glance, it might even resemble an otherworldly alphabet, as if a highly intelligent civilization is trying to send us an alert message. But this mystery is already solved. We are in De Hoge Veluwe, a Dutch national park located in the province of Gelderland. And these lines are actually part of the park's logo. Search for these coordinates to find what looks like a land formation straight out of an extraterrestrial landscape, or perhaps a set from Avatar. This place, located in Inner Mongolia, China, is believed to be a granite mine. But it's a bit of a mystery why it has such a striking blue tone on Google Earth. If you check it out on Microsoft Bing Maps, for example, the same location appears in a much more natural tone. In the Australian outback lies a massive geoglyph known as the Maori Man. Discovered in the late 90s, it appears to represent an indigenous Australian man hunting with a boomerang or stick. The figure stretches for more than 2 miles in length and about 1.6 miles wide. It has deep furrows carved into the ground, which adds to the complexity of its formation and origin. Despite efforts to uncover its purpose, its origin is still a mystery. This is Desert Breath, located in the Sahara. Like many things you have seen in this video, this formation also sparks speculation about it being created by extraterrestrial beings. But a quick Google search clears up that mystery. It turns out this is an art installation created by a group of 3 Greek artists back in 1997. They went all out, moving around a whopping 280,000 square feet of sand and even creating a large pool in the middle of it. Egypt still holds many mysteries, and you can explore them yourself with Google Earth. That's how some people stumbled upon this striking triangular-shaped plateau and immediately jumped to the conclusion that they discovered a hidden pyramid. However, experts quickly dashed their hopes. They believe there's no plausible explanation for a pyramid to exist in this area, located 8 miles west of the Nile Valley edge in Upper Egypt. This discovery is likely nothing more than a hill that has suffered the effects of erosion, combined with a heavy dose of wishful thinking. In some cases, nature itself is responsible for creating frightening sculptures, like the Badlands Guardian in Alberta, Canada. If you look at it from above, you'll notice not one, but two human heads emerging from the landscape. These gigantic beings were sculpted by rainwater erosion on layers of clay-rich soil. Ironically, additional human-made structures give the impression that this one is wearing wired headphones. It seems that deserts are a prime spot for discovering strange images on Google Earth. So our next stop is China. In the Gobi Desert, you'll come across zigzagging white lines that look kind of random. The first challenge for armchair experts was figuring out what these structures were made of, as it's hard to tell if they're painted on or dug into the landscape. There's still a lot of speculation about it on the internet. But the most plausible explanation is that this structure is used for calibrating satellites. This way, satellite cameras can focus on these large grids to orient themselves in space. Check out this intact plane that seems to have sunk beneath the ocean off the coast of Crooked Island, Bahamas. Some viral videos claim it's a crashed plane belonging to the infamous Pablo Escobar. The truth is that something lying on the bottom of the ocean can't be that visible, so it's more likely that it's a plane that was actually flying when Google captured these images. However, there is a strong belief that Pablo Escobar did have a plane that crashed nearby, but it was in another part of the Bahamas known as Norman's Cay. You can still spot it in shallow turquoise waters. Just search for Norman's Cay sunken plane, and there it is. If you're convinced that extraterrestrials are already among us, then go ahead and type in these coordinates on Google Earth. Explore the area using Street View, and wow, what is it? Of course, we're not talking about visitors from other planets, but this shadow of a gigantic creature still gives me the creeps. Turns out, it's just a person lugging around one of those 360-degree Street View cameras tucked away in a trekker backpack. So hey, if you take a good look around Google Earth, you might stumble upon more of these elongated necked beings walking around the globe.
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, plop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are two stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These two aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth. If you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun. So its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun, and if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny.
Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why. Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds, but around the equator you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be endangered, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour. And as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off. exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry? Cold and seemingly infinite expanses of the Arctic. The white of the snow is blinding. In this vast and empty space, there's a dark dot. Getting closer, it turns out to be a small research station. One door and one window. An old antenna on the roof wobbles from the strong winds. You're sitting inside this hut in warm clothes, drinking hot tea. An electric generator hums under the table. It's connected to a TV and game console. You take the gamepad and select the video game you want to download. It's about 650 gigabytes. It seems in such a place it will download over several centuries. But you press the button and the game is downloaded on the console in less than a second. Welcome to the world with the fastest and most accessible internet. The internet already works at the speed of light. Phones use a specific frequency of radio waves that travel at the speed of light. You're watching this video using the internet at the speed of light. Most of the data is transmitted through a copper wire or fiber optic cable. This happens so fast that we won't notice the difference whether it's transmitted at the speed of light or not. Wi-Fi also uses radio frequencies to transmit signals between devices. The fact is that the speed of the internet is not about how fast a file travels from one device to another. It's about how much data is transmitted over a certain time. So, let's imagine that data of any size can be loaded at the speed of light. 300 gigabytes of several movies in 8K, 400 gigabytes of a video game with ultra-realistic graphics, 1 terabyte of a project for a graphics editing application, and all of this is downloaded to your device in 1/100th of a second. The internet is a connection between computers. For everything to work correctly, the computers connect to a router. This thing works as a controller. It makes sure that the message from one computer reaches the other without any confusion. When there are too many computers, you need more routers that connect to other routers. You can scale this network indefinitely. To connect millions of houses to the network, developers can use telephone cables. To make this complex system stable, it's served by internet service providers. They're companies that we pay money to access the internet. In simple terms, all information from the internet is transmitted via a cable directly to the Wi-Fi router. It uses radio waves to wirelessly transmit data to a computer or phone. Your devices are also equipped with an antenna that can catch and transmit signals via radio waves. The speed of the internet slows down when it goes through different routers, receivers, and other technical hurdles. The cable may be damaged. Providers limit the speed intentionally and increase it when you pay more money. Also, the speed of the internet is affected by the number of users connected to the same network. It's like a broad highway with a traffic jam. The more cars there are driving on it, the slower they move. Just like that, your data is loaded onto your devices. To spread the internet at the speed of light everywhere, developers need to improve cables data passes through. The number of networks and routers should be increased. The jammed highway will become even broader, and cars will be able to drive at full speed. Providers should remove all restrictions as well. Every mobile device and computer should have a high-frequency antenna that catches signals from an ultra-fast router. Several huge routers are located all over the planet. They look like enormous boxes without windows and with giant antennas on their roofs. Deep underground, thick cables providing ultra-fast data transmission are connected to these boxes. As soon as the signal from the cable enters the box, it broadcasts to space via radio waves. Thousands of satellites hover over the planet and intercept these waves to spread them throughout the world. So, anytime and anywhere, you have access to the internet that's working at the speed of light. Movies and video games are created several times faster. A lot of time is spent trying to transfer a terabyte of data with graphics from one computer to another, which is located in another country. Now, with Super Internet, developers get any amount of data in an instant. Flash drives and hard drives are no longer needed in the world. Everything is kept in cloud storage. From there, you can download any file to your computer thousands of times faster than if you downloaded it via USB. Companies that provide cloud storage services are becoming the richest in the world. You have access to the internet in the elevator and the subway, in the mines deep underground, and among the hot sands of the Sahara. The phones are released without internal memory and with an incredibly cool camera. You can record an infinite number of videos with 16K quality and not think about where to store them. You can do color correction, develop games, or edit your videos all on your phone. You don't need powerful processors for such operations. Everything works with the internet. You remotely connect to a powerful computer and work from anywhere. That's why the market for expensive computers has collapsed. Nobody wants to spend money on a cool graphics card because a new one will be released in a year. It's much easier to connect to the computer where it's already installed. Even in our time, such companies already exist in great numbers. You can play a new video game on top of settings on your old computer or phone if your internet connection is fast enough. Super Internet creates a perfect climate for the rapid development of modern technologies. Virtual reality lenses, for example. On an airplane, in a submarine, in the desert, you can watch the highest quality movies in 360 or play games with augmented reality. Special effects and graphics in such games become indistinguishable from reality. Artificial intelligence can process data from all over the world simultaneously, in seconds. Thanks to this, people make discoveries in the field of medicine and genetic engineering. Scientists are developing a machine that can upload the human mind on the internet and download it back. Each user's cloud storage accumulates so much digital garbage that people hire special companies to clean up terabytes of useless data. A huge amount of energy is consumed. It provokes an increase in the price of electricity. To save money, people build small wind farms in their backyards to generate electricity. Many people make tunnels to get to underground rivers. Using special equipment and a powerful water flow, you can create a home hydroelectric power plant. The roofs of most houses are covered with solar panels. The internet is becoming as familiar to the world as the air. There's no longer a place where you can't connect to the web. Some vloggers put a phone in a box made of refractory metals and threw it into the mouth of a raging volcano. Even then, the connection wasn't broken until the phone melted. In a few years, the data on the internet as a whole increases thousands of times. Billions of petabytes must be stored somewhere. Developers around the world build data centers to support cloud storage. They appear underwater, underground, in the mountains, and even in forests. Scientists understand there won't be enough space for such data storage in the future. In addition, all centers emit strong radiation, which is bad for humans and the Earth's atmosphere. Therefore, the world's IT companies unite to create a giant data storage server in space. They build such a station in the orbit of our planet. Developers install special equipment there to ensure the operation of cloud storage. Every year, the station grows in size. It receives energy from solar panels. After a few decades, the data center becomes a cube half the size of Earth. You can look out the window and see its outline in the blue sky, better than the moon. At night, millions of light bulbs glow on it. An enormous area on the moon is covered with solar batteries to provide the cube with additional energy. Now it looks like a disco ball. Humans colonize Mars and take the super internet there. Now you can make a high-quality video call to a friend who is on the red planet. Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under two continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stefan's Quintet. This photo was also posted on July 12th. Stefan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even 2 moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxy's nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
Experts explain Africa is splitting in 2, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago.
For every 1.8 degrees Fahrenheit increase in a country's average temperature, the GDP per capita drops by at least 1.1%. To put it simply, with every step you take from the North Pole to the equator, not only do you get hotter, but you also get poorer. Even though life in freezing cold countries can seem miserable, 74.2% of the world's billionaires are concentrated in the global north. And there are at least 4 theories explaining that. The simplest theory is tied to biology. Cold weather is believed to keep germs away, leading to better health and productivity. Sounds good, but I'll challenge that later. Next, there's the sloth theory from ancient Greece, and it's more about climate in general. Greeks believed their ideal weather made them wealthier, while hotter regions were seen as less creative. The third idea is based on economic and anthropological studies. You see, experts noticed some time ago that colder countries have inclusive institutions that offer equal job and life opportunities and protect markets and private property. Naturally, such conditions promote healthy competition and boost wealth. The last idea is tightly connected to the previous one. Long story short, richer countries tend to distribute money better because they're more inclusive. Poorer nations often have extractive institutions where a powerful elite controls wealth. While all of them seem plausible, the truth is, these ideas are borderline insane. Well, you know the theory claiming that cold climates eliminates germs and the population of colder countries doesn't get so sick? I don't want to be the bearer of bad news, but the cold actually makes germs thrive. In the cold, we tend to stay inside with the whole house shut, so we share germs with each other more easily. Not only that, but during winter, the air is drier, creating the perfect environment for the flu virus to flourish. Humans are also more resistant to viruses and bacteria from their own environment because the constant contact with them makes our immune system stronger. If you look back at your history classes, you might remember that most British people struggled with the weather and bacteria found in America, while Native Americans themselves were mostly fine. And what about the sloth theory? Sorry, I don't mean it to sound offensive, but some specialists, they claim that, people in hotter countries tend to be lazier. But the truth is, the sun doesn't make us work less. Yes, the sun can make you a bit slower because you can dehydrate. But you see, the human body is biologically adapted to the climate of the place they're born in. This means that if you live in Canada, for example, you can endure the cold just fine. But Brazilians will probably handle hot days better than you. But if the sloth theory was true, how would you explain that people in Colombia work about 200 hours a year more than those from the United States? In fact, if you live in Cambodia, Myanmar, or Mexico, you're bound to work more than anyone in the world. Besides, hotter countries have a genius way to fight off laziness. It's called siesta. After lunch, it's normal to feel a bit sleepy, and if you have heavier meals like the Spanish and Italians do, you'll get extra slow. This is why after lunch they usually have a siesta, also known as a quick nap, which improves your memory and thinking skills. It may sound like a siesta makes you work less, but people who nap after lunch simply work at different hours of the day. While you make shorter lunch breaks and go home at 6 p.m., in Spain, the lunch break lasts 2 hours and the workday ends at 8 p.m. They work when it's not so hot outside and even get to take a power nap. The past is also crowded with people who lived rich lives despite the scorching sun. The ancient Egypt civilization may have existed thousands of years ago, but they were one of the richest civilizations ever, even though they lived in a place that was super hot and super dry. We also have the Aztecs, who lived in Mexico back when Mexico didn't exist yet. This region is not so famous for its cold weather, I can tell you that. But the Aztec civilization still managed to have a capital that was bigger than London, Paris, and Madrid of the time. On top of that, many of the inventions we have today that make a lot of people rich were created thanks to math and science. Two things born in hot places, like Mesopotamia and India. Now, to make all those economic and anthropological studies sound simpler, let's start with the most obvious part. It's true that hotter countries usually make money out of their natural resources. They don't have such strong industries, and the money is concentrated in the hands of the elite. All of this reduces the GDP, that thing that estimates whether a country is wealthy or not. Remember we said richer countries have inclusive institutions? These institutions are basically laws that make sure people have equal job and life opportunities, including nice houses and a good salary. Poor countries are not very good at this inclusive institution thing, but it's not by choice. This is actually a consequence of the age of exploration. In case you were sleeping during your history classes, let me remind you. The age of exploration is that time between the 15th and 17th centuries, when many kingdoms in Europe were exploring the seas and setting up colonies all over the world. I know it feels like this was a long time ago, but many countries that were colonies back then only became independent during the 20th and 21st century. This is why many poor countries don't have solid industries and markets, because their institutions and laws date back to when they were still colonies, and their years as colonies depleted resources and didn't provide a good infrastructure. Besides, saying that private property reduces the income and inequality gap is kind of absurd. It's true that developing countries like Brazil and South Africa are highly unequal, but in the US, for example, 1% of the richest people in the country make 139 times more money than the poorest part of the population. And there were more than 700,000 homeless people in 2024. Besides, 1% of the world's population is wealthier than the rest of humankind put together. If inclusive institutions were really that powerful in richer countries, then there wouldn't be more than 1 billion people living in acute poverty all over the world. There's no point in saying that private property makes everyone's lives better if people can't even afford to have a house in the first place. And using the GDP to calculate the wealth of a country is not exactly the best way to understand poverty, because the GDP only considers how much money the industry itself makes. It ignores, for example, the question of whether people who work in those industries have good jobs, if they are well paid and have a good life. The GDP also ignores inequality, which means it ignores those inclusive institutions we mentioned before. In the United States, there are about 835 billionaires, but 11% of the American population is still very poor. So, my hot take here is that inclusive institutions are not that inclusive, and that money is not that well distributed in the first place. Different cultures also have different concepts of what it means to be wealthy. In London, for example, being able to afford food, clothes, and shelter does not make you rich. To them, you're simply surviving. If you want to be truly wealthy in London, you might have to hire a housekeeper, buy a horse, and have a personal Pilates instructor. But to the Awa or the Yanomami tribes, money doesn't even exist. They produce only the necessary, and if they have a surplus, they will trade with other tribes. I guess the fact that poor countries are all located closer to the equator line is not just a simple historical coincidence.